In this hands-on experiment, we're going to look at how light can affect the growth of a bean plant over a 3-week period. Now, several things are going to happen here. First, we're going to set up an experimental design where different groups of students are going to be assigned an amount of time that they're allowed to allow their plant to be exposed to sunlight. Now, in order to do this, students are going to program robots that will lower milk cartons over their plant, thus preventing them from getting any sunlight, and raising the carton to give them varying amounts of sunlight during the day according to the amount of time that they've been assigned. So for example, let's say group 1 has been assigned 1 hour a day of sunlight for their plant, and group 5 may be assigned 8 hours of sunlight. The students will be responsible for programming the robot to raise the carton and giving their plant the amount of time that they've been assigned. After 3 weeks, we're going to look at the different heights of each plant and correlate that, compare that with the amount of time that the plants were assigned. So there are several things going on here. A, we're setting up an experimental design for science and looking at the impact of photosynthesis and whatnot. B, we're also going to be learning robotics and how to program robotics. And C, we're also going to be learning how to use Excel or Google spreadsheets, because we're going to have to do some mathematical calculations that we're then going to insert into our program that's going to determine at what time of day our robot is going to raise its milk carton and lower it. Now, to start off, I built a very simple shelving system, bought a couple of planks of wood and cut them so that they would fit nice and snug into the existing window frames within our classroom. And if teachers are interested in replicating what I did, I have the instructions on the website. Now, in stage 2, we proceeded with a programming lesson with students, and we are using LabVIEW for LEGO Mindstorms to program our robots. But you can use Mindstorm software or EV3 software or any other type of object-oriented programming software. So, to start off, we're going to launch LabVIEW for LEGO Mindstorms. Now, you can download LabVIEW for LEGO Mindstorms at the National Instruments website, and they have a free version that you can trial. So upon launching the software, I'm going to get this screen, but in this case I'm going to use LabVIEW for LEGO Mindstorms and then hit Start LabVIEW. So when you start up the program, you'll hit Create Program, and you're going to choose Blank Robot and then hit Create down here, and it will ask you to give your project a name. So I'm going to put my name with an underscore and call it Plant Experiment, and let's say I was given 8 hours a day to expose my plant to light. So I'm going to call it 8 hours. That way it's very specific, and when I send this to the teacher, they'll know exactly who I am and what experimental group I belong in. If you want to know where your program is saved, here is the path. It's in my Documents folder in the LabVIEW Data folder. Next, I'm going to come to the Project Center, and I'm going to put the target here. I'm going to set it to NXT. Normally you could choose an NXT that's hooked up to a USB. It would be listed in here, but I'm assuming that as students you're not necessarily going to have access to a kit at home, and so if you are programming this at home and you've loaded the software at home, you can do your programming without actually being connected to a robot, and then when you come to school you can just hook up your robot with the USB and test it out. And I'm going to go over here and I'm going to select New Virtual Instrument, and I'm going to target the computer, and once again I'll name it. And I'll hit Create. And I'm going to get these two windows here. I'm going to get this Virtual Instruments window here, which is in gray with a checkered background. We do not need to use this at all, so you're going to completely ignore it, and you're going to select the white window. If one of your windows is missing for some reason, just go to the window menu up here and choose the tile up and down, and that'll bring them both back in plain view, and then you can manage the arrangement of your windows. So I'm going to stretch this one full screen so that I have my full computer screen, complete real estate on my computer screen to work with my programming. Now you're going to need two windows open at all times. One is the Functions palette and the other is the Tools palette. And those can be found if you go to the View menu. You have Functions palette and Tools palette. If you don't see them, select them from here and they should pop up. Now within the Functions palette, you're going to notice that you have four basic families of programs here, programming instructions. We're going to be working with the first two primarily, and I'm going to start with the NXT input-output family. That's the second one here. I'm going to click on that, and you'll notice when I click on it, a submenu of more icons appears. And when you see little arrows here, like these over here, that means there are even more icons. So if I were, for example, if I were to click on one of them, it would open up another menu of icons. So you'll notice that it's a menu of icons within a menu within a menu. If ever you get lost and you want to come back to the first level, just click on NXT Robotics and it brings you back to your main family of programming icons. So again, let's start with this one. And let's pretend that there are 24 seconds in a day as opposed to 24 hours, because we're going to be working in seconds as our units of measurement here while we're programming. Okay, now I'm going to start with this wait for command, which is an hourglass, and I'm going to click and drag that icon out here. You notice there's little dots that appear on each corner. That means you can, later on, you'll be able to use those little dots to connect different bits of information, to give them more specific instructions to perform. I'm going to go over to my tools here. Now, just like when you're building any type of apparatus, you may need a hammer, screwdriver, or whatever. This is my toolbox, and in this case I have a spool of wire, I have a hand tool. I'm going to use this hand tool here, this little pointer tool, and I'm going to click on the pull down menu on the wait for, and you'll notice that my wait for command has many different options. You see, I can make it specific for a certain command. I could say wait for a sound, a loud sound. Before you do anything, you must hear a loud sound. Or I can go to temperature and wait until it is a certain temperature in the room. Then I could ask the robot to do something afterwards. In this case, I'm just going to say wait for time, and it's set to seconds, not milliseconds, but seconds, and I'm going to leave it at that. Now, how many seconds do I want it to wait before it starts the rest of the program, moving on in the program? Let's say I'm going to ask it to wait 4 seconds. So, to specify a quantity for any programming icon, to specify the quantities, you click on the lower left corner of the icon. So I'm going to right click. If you're on a Mac, hold your control key and click on the lower left corner and go to create constant. And you'll notice that a little box with a number in it is now wired in there. I'm going to type, let's say 4, and hit enter, and there we go. It's now going to wait for 4 seconds. Now there are other ways of adding numeric constants. You can actually go into the menu here and you can grab constants from the first family, and here is our numeric constant. You could drag that out and you could attach it to the icon, and I'll show you that later. Okay, now let's say I wanted to change the 4 seconds to 5 seconds because I made an error. Let me go to this text tool, and I'm going to click inside that box, hit backspace, type in a 5, hit enter, and now it will wait for 5. So after 5 seconds, what do I want it to do? Well, in this case, I'm going to have a motor turn on. A milk carton is going to be attached to the motor, and the motor is going to turn on, thus raising the milk carton. So if you move that icon close enough to the other icon, you'll notice that it automatically connects with a wire. That pink line there is a wire. So you're kind of creating an electrical circuit of sorts. So wait 5 seconds, then turn on motor A. Let me switch to my hand tool here, and you can switch your motor on, forward or reverse, or you can turn it off, let it just coast off with its natural inertia, or you can brake it like a solid turning off. I'm just going to have it turn on forward. And next I'm going to specify the speed. I don't want the motor to raise the milk carton full speed and then the carton starts getting all wobbly and that. So let's have it rotate at a slower speed. You right click on the lower left corner of the icon and you go to create constant, and by default it goes at 75%. I'm going to click in there and I'm going to put it at, let's say, 50. You could choose any value you want. I'm going to take my arrow tool over here and I'm going to grab that box and just move it out of the way down there. I know that my milk carton is now rising. The question is, how long do I let it rise? So it's the motor turns on, how long do I let it rise? In order to know how long I want the motor to actually stay on and raise the milk carton, I'm going to count how many rotations it takes for the motor's wheel to turn around, how many rotations it takes to raise the carton fully to the top. Now once I've counted the rotations, I can then take this wait for command, drag it out. Now you notice it's a little too far away from the forward command, so I'm going to have to wire this manually. So I'm going to switch to my wiring tool, go to the top right of the previous icon, click, and while holding down I'm going to drag the wire over to the top left of the next icon, and now they are wired. Next I'm going to switch to my hand tool, go to the pull down menu on the wait for command, and I'm going to choose wait for rotations. Now in this case I counted 6 rotations. It took 6 rotations to raise the carton fully without it actually hitting the shelf or anything like that. You got to leave just a little bit of slack at the top. And so I'm going to add now a numeric constant, that is, specify a value. I'm going to right click on the lower left corner of this icon and go to create constant, and right now it is at 180. I'm going to set it to 6 rotations. Now here's where you have to do a little math. Well, one rotation is 360 degrees. If you want to do 6 rotations, you're going to have to go 6 times 360 degrees. So this is where we're going to go to our spreadsheet. I'm going to jump to Excel, and I've posted a copy of this spreadsheet on the website so you can download it and use it. However, in the second video that goes with this experimental process, I put together a video that shows you how to enter the formulas and to use Excel. Now, Excel is a calculator. Any cell that you click in is actually a calculator. And if you turn on your formula bar, see this f of x bar here, opens up a bar over here, you can type in a formula. I'm going to go equals. Now to start any formula you need to start with an equals, and I'm going to say 360 degrees times, now that's the little star that's above the number 8, so you hold shift and push number 8, 6, and then you hit return and you get your answer. It's 2,160. So I'm going to flip back to LabVIEW and I'm going to go in here and change this number to 2,160. That is 6 rotations, and hit enter. Okay, one little thing I didn't do so far is I didn't specify which motor I'm talking about. Now, on the physical robot itself, you have 3 ports, 3 output ports, or on the EV, you have 4 now. You have A, B, C, and D. On the NXTs, you have 3. And in this case, I've connected my motor with a wire to port A. So it's motor A, because by default, right now, it's just going to do all motors. So to specify the motor, take your hand tool here, and with that little index finger, click on the top center of the programming brick, right click, go to create constant, and then choose, you've got all ports here, click on it and choose port A. And do the same thing for this wait for command, which is now spin. Now if you accidentally click a little to this, a little left to the center or something like that, and you go create constant, you might get like a pink box like this, and that's not going to be very useful for you. So take your arrow tool, click on that box and delete it, and try to get right in the center right click, create constant, and specify port A. Another way that you could have done this, let me edit undo here, is you could just take your wiring tool, click on the wire from the previous port A, and because the second icon is also going to be port A, just click on this wire, drag your spool of wire here, click to anchor it, and then turn down and click on the center, and there, you're now sharing this command of port A with this icon and this icon. Okay, so once it has spun 2,160 degrees, which is 6 rotations, I want it to stop. So let's grab this motor command, bring it close enough so it wires automatically, and then with the hand tool, choose motor off brake, so it stops instantly. And again, I can take my wire tool and specify that it is motor A, that is to brake. Now let's assume that the milk carton has now risen and it should get about, I said 8 hours, so let's pretend those 8 hours are 8 seconds. So I'm going to give it 8 seconds of sunlight. So let me wire this and get my hand tool, right click on the lower left corner, create constant, and I'll give it 8 seconds. So the milk carton is risen, all motors are off, the plant is being exposed, the program does not move forward for 8 seconds, which means the plant is going to be exposed to sunlight for 8 seconds. Well, once the plant has now had its sunlight, we're then going to want to lower the milk carton, and we're basically going to be doing everything we did here but in reverse. So you know what, I'm going to show you a little trick here. Because this is what we would call a routine, this whole group of icons, I'm going to, let me delete this, and you'll notice there's a little wire left over. That's called a bad wire. You can click on it and hit delete. What I'm going to do is I'm going to take my pointer tool and I am going to draw a square around these icons. I'm going to then go to the edit menu, copy, and I'm then going to paste. And I basically have a duplicate, but let me click anywhere to deselect that. But in this case, we are reversing everything. That's the only difference. So I'm going to go to my hand tool, switch the forward to reverse. So now the milk carton is going to start going back down. How long should it continue to lower itself? How long should the motor stay on while it's lowering? Well, we said 6 rotations. In this case, it's going to be minus 2,160. We're going the other way, minus 6 rotations. If you left that as a positive number, this motor would continue to lower forever and ever and ever, infinitely, because it would be waiting for 6 rotations forward. So we're specifying 6 rotations backwards now because we're actually in reverse. It then counts. Once it gets to negative 6 rotations, it knows that the carton is back down and lowered and covering the plant. We brake port A, and how long should we wait before we start over? Well, again, remember I'm saying let's pretend that the seconds are hours. So far we've used 5 seconds to wait and 8 seconds for the plant to be exposed. That's 13 seconds so far. So in terms of a day, we'd have another 11 seconds left. So we'll make it wait for 11 seconds before it proceeds to continue the program. But there is nothing else left over with this program. Unless, in other words, it's just going to run once. And then when it gets to the end here, there's nothing. So in the last part of our programming, we're going to add an actual structure here called a loop. So the loop, if we go back to the first menu of programming families here, and we go to the first set, which is NXT programming, and we go to structures, We could then choose the while loop. Click on it and come over here and draw a square around your program. Your program is now going to loop infinitely. Now if you want to specify when the program can be stopped, you will do the following. We will go back to our NXT.io family. We'll go to this library of complete icons, go under the Sensors submenu, and I'm going to drag this Read NXT buttons. That is the physical buttons on the NXT itself. And now that is wired to the stop button. And then I'm going to click on the lower right of this, create numeric constant, and it's the enter button. So this loop, this program, will run continuously until somebody physically hits the enter button, which will stop the loop and stop the programming. Now we have one little detail that we missed in here, and programming is all about details, and our actual loop would not run here. There's actually a mistake in here and I didn't notice it, and that is we did not wire these two sections together. So I got to go back, click on this, and then wire it. And now the program should run just fine, and we can run it on our NXT.